So the very last thing that we want to do is we're going to show that visualization. And this is where it gets really kind of fun in my mind. But what it's doing is it's showing you pedal width, pedal length, sepal width, sepal length, and then sepal length, sepal width, pedal width across the bottom. So it's charting each of those different possibilities with the other ones. And then the color shows you the three different types of flowers. So now immediately you can see that this is not just random data. You can see that certain types of flowers have certain characteristics. And you can see how different Setosa is than the other two flowers. So when we dropped that machine learning algorithm down so that it was only training on 10%, I guarantee you, without even having to look at it, that the two types of flowers that were getting confused for each other were the green and the orange, because they're much more similar than the blue, right? So you can see here on petal length, if I do petal length by petal length, this shows me a histogram of how many flowers have that length of petal. So almost all of them are within that tiny, tiny little bit. So if you start to think about the data and what it means and how it's shaped, now you're thinking like a data scientist. You're using these tools, not just one by itself, but you're using all of these different things together, the data cleaning, the predictive analytics, the machine learning, the visualizations, and the idea of big data. The more data you use to train that machine, the better, right? Because when I train it using 60% of the data, it's not going to miss, period. So it allows me then, I could get 800 more flower data, and it's going to, if I train it using probably, I don't know, 50 flowers worth of data, my odds of being able to predict what kind of flower it's going to be, or even in the reverse, I could tell it, if give me a flower that would represent a Setosa. I could go back the other direction now. I could say, I want a blue flower. Give me a measurement that would represent that flower really well. It can go the other way. So that's what predictive modeling allows us to do, is actually create data when it's not there, based on the probability of what we know. So that is machine learning. I think it's very interesting. And for your sandbox today,